Now, how did the universe come to being? Well, it's believed, the current theory is the Big Bang theory, and it's believed that billions of years ago, there was a huge explosion. Now, what caused that explosion is still being debated about, but this huge explosion and everything started moving away from the centre of the explosion, as things do when things explode. Scientists can see enough in the universe to suggest that that movement is still happening, that the universe is still expanding. And this gives evidence that is consistent with an explosion idea. Other evidence. There are really three things that you need to know. The other evidence. The first one is that there is cosmic microwave background radiation, or just heat, really, which is thought to be an echo of the initial explosion. The average temperature of the universe is thought to be about 3 degrees Kelvin, which is very, very cold. This indicates that the universe is still cooling down after an explosion, because they think that the average temperature should be about 0. Secondly, when astronomers look at galaxies through a telescope, they still seem to be moving away from us and each other. This gives evidence that the universe is expanding, which is consistent with an explosion idea and parts moving apart. Lastly, Hubble came along with telescopes and made observations about something called red-shifted light, which I'm going to explain now to you. This suggests that the universe is still expanding after the explosion. So that was consistent. Redshift. So redshift is consistent with the universe expanding. So there are the three things: that there is microwave background radiation, which is consistent that the universe is still cooling down after an explosion. It suggests the universe is expanding, meaning that the parts are still moving apart. And it's also suggested that light that reaches us from distant galaxies has been redshifted. And I'm going to explain that now to you. So those are the three things you need to know. Okay, this is an explanation of redshift. When objects move away from us, their wavelength increases and their frequency decreases. Now, if you look at this picture of the young boy, there's an ambulance moving towards him. As ambulance move, the sound waves that it gives out are squeezed together as it moves towards you, but spread out after it moves away. So whenever you hear the sound coming towards you, you're hearing sound that is a small wavelength, but a high pitch. Whenever the ambulance moves away, however, the same thing's happening. The waves in front of it, are the sound waves in front of it from its siren, are squeezed together, higher pitched, but the waves behind it are actually lower pitched. And that means they have a longer wavelength. You can see the distance between peak to peak, there's much longer there than it is here. This is called the Doppler effect. So the bit that we're interested in, the redshift bit, is about the wavelength becoming longer. And that only happens whenever objects that make a sound are moving away from us, or that's when we hear it. So how does that tie in with the universe and what astronomers observe? Well, different stars are made up of different elements, which all give out different colours of light when they're very, very hot like that. So I'm sure you've done flame tests in chemistry. For example, a lot of stars contain sodium, and sodium emits yellow light. So different stars emit different colours of light, and this enables astronomers to identify them one from the other. When light from distant stars and galaxies are viewed on the Earth, their wavelengths, the wavelength of the light that they emit, appears to be a bit longer than it should be. And remember what we talked about a minute ago, when objects move away from us, their wavelength is bigger. So that is consistent with light from distant stars and galaxies moving away from us. So that's what redshift is, whenever the light from distant stars and galaxies move away from us. So why is this called redshift? Well, we know that light is white normally, but if you can disperse it through something like a prism, you get 7 different colours. And there's a little rhyme: Richard of York gave battle in vain. So you have red, orange, yellow, green, blue, indigo and violet. The different colours of light have different wavelengths. And red light has got the longest wavelength, but violet light has the shortest. So that means that whenever the light comes towards us from the distant galaxies and it appears to have a longer wavelength, we say that it has shifted towards the red end of the spectrum. And that's why it's called redshift. So just to recap what redshift is again, when light comes to us from different galaxies, it appears to have a longer wavelength than it should. We say that it is shifted towards the red end of the light spectrum, and therefore it's evident that those galaxies and stars and so on are moving away from us. And that's very consistent with expansion due to a huge explosion. Okay, so Hubble did a few observations with his telescope, and he also noticed lots of the galaxies, the light was shifted towards the red end of the spectrum. He also noticed that the further away a galaxy was, the more its light was redshifted. But what he concluded was that most galaxies were moving away. The further away a galaxy was, the faster it was moving. And he came up with the conclusion as well that the universe is expanding. Again, very consistent. Now, the other theory, which isn't well believed, is the steady state theory. So there are two theories for the formation of the universe. The Big Bang, and we've given 3 pieces of evidence for that, then the steady state theory. And this theory states that the universe is expanding, and as it expands, matter is just created to maintain a uniform density of matter. In other words, just to fill the gaps, which doesn't seem that reasonable. Evidence, again, that the universe was expanding, so Hubble's observation about redshift fitted in with that. However, since he discovered cosmic microwave background radiation, where the universe is still cooling down, this theory is much less popular and really isn't believed very much at all.